Right. Should be live. Audio balance looks about right, just in the OBS UI. I say to a non-existent audience. Okay, yeah, so wanted to play this for a while. Should be doing some programming anyway today. I'm actually not going to be doing the stuff I'm thought to be doing, so instead I'll just play video games with programming instead. Right.
Hey, can you hear me? I heard you were looking for some medicine for the phage. Looks like you definitely need it. So, I do have a source. I know where to get it. It's cheaper than the real deal, but it's still gonna be pricey. The going rate is 700 a dose. You need to take one dose every day. Yeah, that's dollars. Sorry, I don't set the prices. I'm just a courier. It's not like any of that money goes to me. Anyway, if you do get the money, give me a call.
Okay, case sensitivity 9. There's the A key being a problem. See, they're making out like the semi-mass, but it's not that uncommon to have to literally copy some stuff over from here to here manually. Right. Just because, yes, you could automate it, but automating it would be higher than just doing.
Wow, a whole 10 cents. Congratulations. You only need to do 6,999 more of these, and you'll have enough for today. Don't worry about that right now. You need that medication to stay alive, right? Well, guess what? I can get it to you. You'll need to start hacking again, though. One hack, one dose. Easy. Deal? Sure you can. Knock knock.
Hey, came by to give you something. I can't hack like I used to. Whatever edge I had, it's gone now. But I had to keep doing something. Something to keep the culture alive, you know? Computers are running everything these days. Before long, human beings aren't even gonna have a say. So now I equip people with knowledge. the knowledge to make a computer do what you want on your terms. Anyway, I won't keep you. I know you like to be alone. Hope you like what you see in the zine.
Right, so I've already got the issue on screen. We'll just be referring to that as and when we go. Okay. Okay. So, do file 200 output. That's gas walks you through it in the. I'm actually skipping a bit in. Oh wait, no, here we go. Tutorial on the basics. Got it. So I did see a stream of this before, so I've got a basic idea what it is. I know ultimately it's a visualization of state mapped on a for it, assembly-like language, which a few years since I've written any assembly code, but so far it doesn't look like it's anything too complex. So let's see. File to the end. Don't need. Right. So, I mean, they did just give you the solution, yeah. It's link 800, which tells the XA specified here to move on to this, move across this barrier by code 800. So it has to move back again by doing link -1. We then grab 200, which will cause it to file. We would then link 800 again, so we're in the state of being in the inbox and we want to go to the outbox to release the file, and then halt to tell it to remove the exit. Is specified here. So it says that we can step. Yeah. So this will show us what happens at each stage. So that moves into the inbox area, picks up the file, moves into the outbox area, releases the file. Looks like it has to complete a number of test runs in order to clear the stage, presumably just so you don't just effectively clear it by chance. I'm curious. Drop instruction necessary. Is it? What happens if I halt while I'm holding a file? But okay, that leaves the file behind. Okay, so that's actually slightly more efficient. Is okay, so if we drop a file that so if you're holding a file and you delete the exit, that run now. There we go. And as you can, not very surprising. Got a optimal result. I'm curious. Like, I'm sure this means returns to the Exapunks desktop. Okay. Right. Add the first two values of file 200. Multiply the result by the third value at the fourth. And the result to the end of the. But again, it's another case where the answer is just given to you in the book, but we'll work through it anyway. Got link 800 to move there, grab 200 to pick up. Okay, so the next command they give you in the example is copy fx. So f will be a register that's pointing a. Okay, so my understanding is that f is a pointer to a value in a file, and anytime you interact with f, it advances by one state. Okay, so we're copying the first value into there, then we have add ixf(x). So this will be a command that says sum the value in x to the value in f, go back into the value of it into the register x. I've not looked at the full instruction set. I assume that add I implies that there will be floating point arithmetic and it's explicitly integer arithmetic. But I'm not 100% sure on that. Maybe it's just make it look more like actual assembly code, and maybe it won't get to the complexity of point or not. Anyway, we then have to multiply in the same way, subtract in the same way, and the f effectively will now be sat to the file, so we can see the result in. And then we have to move it into the outbox, and we have a drop command in here in the example given. As before, we've established we don't actually need that if it's the last thing we're trying to do, so we'll get the right number of A's in. Okay, so let's give this a go. Oh, some people have managed to do it shorter still. Presumably. At least some way of collapsing the arithmetic operations, I would guess. If I take it seriously, but for now, just keep working. Right. File 199 contains 32 values, keyword, and a number. Create a new file in the outbox and copy those two values to it, swapping their orders so the is first. When you are finished, delete file 199. Right. And the thing that the book highlights here is that the link going to this secret area is one way. There's no link command we can use to get back to the inbox area. So that means that we are required to have two of these exit robots. So if we create exit, so the first thing that we need to do is send exit A to the secret area. Link to, and oops. And then exit B needs to go to the outbox area. So it looks like, what do we say here? Create a new file with make. File it creates will be empty alt. Next, can delete the file it's holding with a wipe. Two X's communicate using M. If one value writes to M and the other reads from M, the value gets transmitted. If an X is reading the M while no one's writing to it, it'll wait until another X picks up the other end of the communication. You don't need time perfectly. Okay, so it's a blocking read. The toggle switch in the Exodus user interface that lets you set the M register to a global or local operation. In global mode, two X's can communicate anywhere in the network as long as there's a path of links connecting them. In local mode, two X's can only communicate if they're in the same host. Finally, an Xer in global mode can't communicate with an Xer in local mode even if they're in the same host. Okay, that's probably for in more complex cases where we have a greater number of Xers to try and control who's communicating to whom. So XA will be in the secret area, so that can grab 199. XB might as well start doing work and make. Do we need anything else with the make command, or is it just make? See what that Not quite sure I followed what happened there. So, do these not run simultaneously? I assume that they would be like both moving. Yeah, I'd have thought they would have both moved together. They alternate. Is XB running first? Strange. Or yeah, I'm not sure why they're, unless only one thing can go down a link at a given time. And balance out. I'm not sure. Anyway, what we need to do is copy from MX. Oh wait, hold on. Copy from F to X. You've made, you need to copy from. I assume when you make, it grabs as well. Like when it makes a thing, it'll hold on to it. So if we copy from, oh sorry, not from X, F. Copy from M to X. Do that again. F to X. Copy. M to then wipe and hold. Copy X to F. That looks like it should do the right thing. The only concern is because we've got two writes to M happening one after. It's not a blocking write. It doesn't wait until something's read from it before it can write to it again. So I don't know whether we need to that. So yeah, that file is initialized to grabbed. So you're blocked waiting on M. You've picked up the file. Read the word echo into M. We put X. Yep. Okay, that seems to have done the trick. Okay, looks like we could have done slightly better. But fairly happy with that. Right. File 200 contains exactly one number n. Create a new file in the outbox containing n through 0 in decreasing order. You'll finish delete file 200. Right. Well, without even reading it, I know that I need to move into box and pick up the file. Okay. So reading this, you can compare two registers and or values with the test instruction, like testing if x equals 38 by using test x equals 8. If the test is true, the T register is set to 1. If the test is false, the T register is set to 0. On their own, test instructions aren't useful, but if you combine them with conditional instructions such as T jump and F jump, you can jump to different parts of the program depending on the result of the test. T jump is jump if true, and F jump is jump if false. You need to specify the jump target with a mark instruction somewhere else in your program. Okay, so what we want to do is read out the one number of that thing. So copy F to X. Let me read. Okay, copy F to X. Okay, wipe. Link 800. Make. So we've wiped the inbox file. We're creating a new file. What do we need next? There is the question. Does the number n, is number n guaranteed to be greater than 0? If we can assume it's always greater than 0, we can just make a new while loop effectively. Whereas if we have to check whether it's already 0, we're going to need two branches. One to enter the loop, and then one to, I guess, we need two branches, but we only need one test because the second branch can be an unconditional jump. I assume there are unconditional jumps in this video language. Yeah, we'll do it as a while loop rather than a do while. Yeah, that go. Mark loop, and it gives you a nice highlight there. Okay. Oh, that means you're gonna have to do all your subroutines manually. It'll be fun. Hopefully you get more registers in later levels, but you gotta do more complex subroutines. Anyway, mark loop. So what we need to do. Oh wait, no, that's yeah, that is right. Okay. So what we need to do is do test x equals 0. T jump. And then mark. And hop. T jump. Okay. If x is 0, then on the next instruction jump straight to a halt instruction, so that'll drop the file, delete the exit, we're done. Otherwise, we want to copy x to f, and then sub I x 1 x, subtract 1 from x, okay? And then, is there a, need like a cheat sheet to see if there's a branch. Oh, here we go, instruction continued. Branching. Okay, yeah, there is just an additional jump. Jump. Do a loop. Right, so let's just get through. There, grab the file. Cache value, delete the file, the outbox, create a new file, check to see if we need to loop. That not. That was false. Or. No, I'm not actually. Okay, I thought the indication was that the T register would get set to 1 when the test instruction runs, or is that 1 getting swallowed by the T jump? Oh wait, no, I'm an idiot. Okay, yeah, because my condition is a failing condition, so yeah. Oh, okay. So that's failed because it needs to be when it's. We need the 0 to be written there as well. Okay, is less than allowable? Looks like it. Okay, yeah. I think I should solve it. There we go. Oh, quite long on the cycles count. I wonder how people are doing that quicker then. Maybe there's a way to write instructions kind of. Sorry, write values en masse. Alright. Cause a pizza to be delivered to your apartment. Important. Okay, so they've immediately made this somewhat more complicated. Append your order file 300. The end of the order list, file 2. Note that all orders, including yours, will get exactly 5 keywords. File 300. Okay, so most of this is kind of redundant. So where's file 200? File 200 here. Go goal. Okay. Well, probably the easiest way to go about doing this is to just make another exa, so that one of them can be reading values into the M variable, writing them out. Because otherwise, I think the only other way you could do this otherwise is effectively take file 300 across the link with you, and then keep grabbing it, reading a value, dropping it, writing a value, and so on and so forth. Because like an exa can have one value in scope at a time. Let's make a second exa. Move 800. Oh, right, link. Link 800 and then grab 200. And grab 300. Does it block on right is the thing. Like if I just copy F to M. See, I could just because we know it's going to be 5, I could just effectively unravel the loop and just do this 5 times. Let's just do that. It makes our instructions a bit noisier, but it means we're carrying like this. Because otherwise I have to effectively write a loop to 5 iteration. Isn't ideal. Okay. How do I seek to the end of a file? I need to append it. Okay, so we set to range from it. Reading or writing. Going to the end of the file, append the new value to writing. Okay, so there's a seek instruction. If seek would move the file move the file forward or backwards to the specified number of values. If seek would move the file cursor past the beginning or end of the file, it will instead be clamped. Thus, you can use the values of -9999 or +9999 to reliably move to the beginning or end of the file. So therefore, we want to seek 9999. That just type. Okay, that's because we didn't have focus. Okay, seek to end the file. Copy M. Copy M. Right. If I hold both of these, that should be enough to do it, assuming that the interactions with M is the problem. Yeah, okay, so it looks as though read and write operations to M are both blocking operations. Is good to know. I apparently just ordered 100 pizzas. Yes, I'm guessing the only way to bring down the size is to use a loop rather than doing it in line, but because of the need to branch and label and etc., your loop is really going to be anymore. Where's the you're an AI? Yeah, you see, that was kind of blindingly obvious. Oh, where's the not at all button?
Pizza delivery.
That's a terrible joke. Bad joke.
Don't look too surprised. I'm an independent operator. I handle a wide range of businesses. Economy like this, you gotta hustle.
Ah, yes.
So, here's your pizza, and here's your other package. I hope it helps. Good work getting that money together. If there's anything else you need, you know who to call.
Whispers. Oh. I had no idea you could put donuts in the broiler. But there was some off-site stuff in the pizza thing. So we've got hack your boy to repair a damaged arm. Cause the last stop factory to free. We'll just work through them in order. I assume they're just increasing difficulty. Right. Read a value from a nerve connected to your central nervous system. The CNS. Okay, so that's this guy. And relay it to the nerve connected to your arm. Clamping the value that it never goes below -120 or above 50. Since this task is placed inside network you control, it's not necessary to leave no trace. Your exit should be written to operate indefinitely. Sorry. Note that nerve is a hardware register, not a file. You can use it directly in your code like any other register. Okay, so I don't need to pick them up. So we're going to need 2 X's. One to... well... I don't know, actually. In the interest of... what does activity track, anyway? Number of X's you control... execute link or kill instructions. Okay. I score total number of instructions in all your X's. So I was going to say, you can do this with 1 Xer by just reading value and taking it over to the other side. Alternatively, you could do it with 2 X's where one stays at the nerve and the other one... sorry, one stays at the CNS and the other one stays at the arm. And then they just pass values across using the M flag. We'll try it with 1 and we'll see how it looks. So, move 800. Sorry, I keep doing that. Link 800. Right, link 800. So now we're in this area. So we need copy. Do I reference it with a hash? I do. Copy hash nerve X. Okay, test X is 11. -20. T jump to, let's call it seal. Not make, mark, seal. Test is greater than 50. T jump, floor, mark floor. Mark. Move. Okay, and we also need to do mark start. So for the move, we need to link 1, link 1, link 1, link 1. That'll go there to there to there to there. And copy X to hash nerve. Then link -1, link -1, link -1, link -1. Jump to start. And then the sealing operation is, okay, how do I just copy a, yeah, I guess it's literal. So copy -1 to X, jump, move, copy 50 to X, move. So I think that works. Move into there, that's our initial. Grab the value. That's exact range, hope it writes it. Find an example that's out of range. Give me one so far. Right, well it passes. So high cycles, which is predictable. High activity because it moves around a lot, but average size. Okay, so I think the single Xer approach is not the best. Let's see how that works. So let's try again with a different approach. So this guy's going to be link. So let's just sit this guy at the arm. Link 1, link 1, link 1, link 1. I get the impression that negative links are there to imply that you shouldn't ever be going that direction. Like, it makes it read as though you're going back on yourself. So, just realised I have actually no idea how well the audio is picking. Spent an awful lot of time talking on this stream, although my only watchers is myself. I don't think I'm missing it. Right, so I guess what we need. Can I copy and paste stuff from here? Ah, excellent. Okay, so we need that. Copy. The truth is, it doesn't. I don't think it necessarily matters which of the two X's does the clamping, because there's not anything that the other one could be doing while it's clamping in either case. So in either case, you've got a wait time. We might as well. We'll just make the second X to do it. So here's that. Right. Copy. Next. Hashtag nerve. Change the jumps to this. Oops. Okay. And I guess all this guy needs to do now is do that, because if writing to M is a blocking call, there's not actually anything else for Xer A to do apart from repeatedly read from the nerve and write to M, because the other Xer will be reading from M and doing the work. So we'll try that. So yeah, this guy's now blocked because he can't advance until that value's been read. Oh, it's a jump instruction. There we go. Okay, so that brought down the size. Sorry, no, I'm lying. The size didn't change. I'm still using the same number of instructions. The cycles is now a lot better, although clearly could be better still. And the activity is about as low as we can get it, as far as I can see. So, big improvement for using 2Xs. Get used to having think it'd be more that you'd get used to not having one. Oh, so you're just getting effectively hints down here. Right. Peanut free, peanut. Right. Move the word peanuts, which is provided for us in file 300, from the peanut blast recipe in file 237. Note that the target keyword will appear in a different position in each of the 200 test runs. You can debug each of the different test runs. Click the arrow buttons next to the test run displayed above. Okay. Oh, so are the test runs all predetermined then? They're not actually randomly generated? Or if they are randomly generated, they're randomly generated when you enter a given stage? I guess. Alright. Okay, right. So grab 300, copy F to X, drop, link 300, link 100, grab 7, and they've quite handily given you a temp register there to use while you're in this area. So, right, what have we got for file manipulation? Because I'm going to need two things here. I'm going to need to know, am I at the end of the file? And I'm going to need to know how to actually remove a single element from the file. Okay, so there's a test EOF. And there's a void F. The void F deletes something, and test EOF just tells you are you at the end of the file or not, so that's fine. Okay. So, copy F. Typing in the wrong window again. Copy from F to temp. Okay. Copy from F to temp, and then test that X equals temp. F jump stop. Does test EO? Okay. Mark start. F. Jump. Finish. Mark finish. Halt. Okay. So now we just need to do a seek -1 and avoid F and then a jump start. And I think that's enough to do the trick, right? Try that. So copy the file, move to there, grab the target file. Are we at the end of the file yet? Nope. Grab the first word. Heck. Matches what we have. Yeah, that didn't delete the word peanuts. Yeah, something went wrong there. Test for execute. So can I not see in what's in temp? How do I... Can I not see what's in there? What does this do? Okay, so why is it doing that? Because it's not... I assume I can't just refer to any old register. Like, if I... Yeah, so that tells me that's not registered. That's not a valid target. So... Okay, well... maybe temp is literally just like a... doesn't even persist, so maybe we can just use M as a proxy. Okay, no, that just blocks forever because we need a second exit to read from M. Am I supposed to be able to read and write to temp? I thought I would have been able to. Oh, right. That's not a temporary register for me to interact with. That's just that is the temperature at which they're mixed, and that's just a fixed value. I can't write that. Okay. There's me getting confused because the word temp has meaning in software development. Okay. Fine. So I need to find somewhere else to carry this value through. Right, because the fact that I've only got one register is kind of sucks. Yeah, I can't really rely on M because you can't... The same Exo can't interact with M because it'll block on write and it'll block on read. There has to be a simultaneous write and read instruction happening in order for that instruction to clear. So... guess the way I could do this is grab 300. Let's take that with us into here. Actually, no. What am I even doing? I don't need a company F to X. I don't need a temp, do I? Drop. Link. Grab. Marks up. Send a file. Jump to finish. Don't need to copy a value. I just need to test what's at the current pointer, don't I? Because that'll advance the read ahead by 1, and then if I do need to delete it, I'll see back 1, delete. Yeah, I was overthinking it, I didn't need a temp. Let's go make sure. Yeah, you see that? That's it, it's sorted. Overthinking the problem. Yeah, well that's... Clearly, other people had better solutions. Oh well. Who am I? Right. I mean, I say I help people when I can. I don't know that hacking into someone's debts is that principled of a thing to do, let's say. Right. Erase gas debt to the copy shop by zeroing out its balance in the customer database, file 200. Yeah. And appending a payment to the payment log, file 201, with today's date and the exact amount of his prior balance. Gas customer ID is available in file 3. More information to network exploration, Digicast point of sale system. There's not an awful lot of extra information in the magazine for this, actually, but okay. So, file 200 is made up of customer ID. What is it? Dollars owed, cents owed. Okay. File 201 is date, customer ID, dollars, cents. Right. That's a thought. What happens if two exits try and grab the same file? I was thinking what might be the quote-unquote quickest way of doing this would be to just have 3 X's, one that just keeps the date pumped. Oh, but I guess... I was going to say you might be able to get away with that because you've got the kill command, so one Xer can kill another Xer, but they have to be in the same area. I don't think you'll be able to get more than one Xer into the date area. Okay. Maybe I should just do this the same way as I did the previous one, of doing the clunky 1xer approach, because ultimately the commands you'd need to do this for multiple X's is the same as the commands you'd need to do with one, just you divide it out. So solving it for 1xer should be then quite straightforward to port to a multi-xer approach, which is potentially more efficient. That might be the way to go. So let's just assume that I'm not bringing that file with me. Actually, no, I think I do want 2 exits. So if I grab a second extra, link 800, link 80, copy, date X, link, grab 201. Yeah, okay. I think I've got an idea. So if we grab 201, seek 999, so we're right into the end. Mark. Stop. What's the right command again? Oh, it's just copy into it. So copy X to F. Right, so that's the only thing that the second Xer needs to do. Because what we're going to do on the first Xer is that's going to grab 200. So that's got the file. And then what we need to do is start. Right. So first of all, we need to test the F equals. So we've got the custom ID in X. So we test whether the thing that we're seeing at the pointer is the custom ID. We want a T jump, which is going to be remove an F jump. Okay, yeah, so no, okay. So you can't do you can't, yeah. Okay. So this block of code now is the block of code we're in if, well actually I guess what we need as well is test EOF. T jump, clean up. Okay, how do we use the kill command? Oh, okay, fine. So you can't target a kill. The kill will just hit any Exa that's in the same area. But that's fine, because XB should be in the same area when this runs. That's how clean up. Right, so in our remove case, we've successfully found an entry that we're interested in, so we go back one. Actually, no, we don't need to even go back one, do we? Copy X to M, copy F to N, copy S to M, jump start. This X is getting beefy. I do like how they keep adding stuff to the X as you put more commands in it. Like this gun thing got added on because of the kill. Okay. So this is in the case where we don't do that. Do a seek to. So advance forward 2 records. And jump to. Because the records are always in groups of 3. Right. That should hopefully do it. XB goes in. What's going on in 201 right now? Oh wait, my cleanup. Okay, my cleanup is not quite right yet because I need to grab 201, seek to the end, then seek back 1, and then do void F. Because the way I've written XB, it always writes a date, waiting for another record, so we need to go back in and clear out that date. Okay, so this is the last iteration. The test end of file, or at the end of file. Go to the cleanup, drop that file, kill XB, grab its file, seek to the end, then go back 1, move that, and halt. I think that's everything. Wait, no, it seems to be done. Raise cast at the shop. Clearing out his balancing. Oh, okay. Right, okay. I've overthought this. Because I've assumed the customer database actually has multiple records per customer. I only actually need to check for his record, don't I? Okay, so let's do that, so then I can just rely on the cleanup. I mean, if I'm perfectly honest, if we assume that he's always going to be in there, we don't even need to do this. Just do. Yeah. So okay. So what I kind of designed it to do was a lot more complicated than what it needed to be, because we know that there's always going to be a record in there, but it's only ever going to be one record. Whereas what I was doing was assuming there'd be multiple records. I mean, I'd missed the bit where I actually zero out his stuff anyway, but yeah. So we don't need the kill. grab. We don't need any of this. Um. Does that work now? You go off and get the. Okay, yeah, that's done it. Oh, we're on low band cycles. Bad. Okay, cutscene.
Hello? You in there?
Hey, I brought you some snacks. It's, well, it's peanut blast, but without the peanuts. I guess there was some screw up at the factory, so now we have a bunch of these that we can't sell. Seemed like a waste to throw away.
How did that get through quality control? I know we caused the screw up, but how did it get out to shops, and why is it then shops who are having to deal with it?
I hope you're doing okay.
Seems a bit.
We should hang out again sometime.
We should hang out again, and you can give me more free chocolate.
I don't have a lot of free time anymore, though. Working at Last Stop's really taken over my life. Speaking of which, I should get back. Take care, okay?
I mean, I probably should know this from, like, I probably should have been paying more attention when I was first starting up. Oh, which is actually my... Am I Mutex? Right. I know there's a thing in the book for me. I saw someone else stream. So write Ember 2's message in file 300 to the highway sign. File contains one character for each position on the sign, from left to right, top to bottom. Okay, so I don't actually need to... Because in the instruction book there's a whole bunch of stuff about the layouting and what numeric digit represents what textual character that gets displayed on the screen. But I assume that they make this more complex, and like there's probably multiple ones where you're writing to one of these rows. But in this particular instance, it looks like it's all been sorted out for me. Okay. One character, left to right, top to bottom. 3 number packets written to cache data. First number is the row, second is the column, third corresponds to the character you want to. Right, okay. So I actually need to... called CLRS, which clears the sign if you write anything to it. The signs or effects you can create, like flashing or inverted text. Right. So how many characters? Okay, so they need to write triples of numbers, a 0 index row, a 0 index column, and then the character you want to display. Right, so I can use. I don't need to actually store the row and column. I just need to know how many characters there are to a given row, I guess. So what have we got here? 1, 2, 3, 4, 5, 6, 7. Is that the same? 3, 7, 8. Okay, so 9 characters for a row. Okay. Enough. I'm gonna assume I don't need to clear it. Oh, that sucks. What is this IMVS? Yeah, so the biggest problem here is the lack of registers, because I only need to keep the count of which character I'm at in the source file, and I can derive the row and the column from that by just doing div and mod operations. But because each Xer only has one register, and as far as I can tell, I can't use any of these registers for free values. I'm gonna have to do some shuffling to make sure I've got those values, so let's... Oh wait, what am I talking about? I can't just do this. Keep. Yeah, because I can just write the operation, the result of the mathematical arithmetic operation straight into the data. I don't know whether I need to clear it first or correctly. Assume we do these things first. I expand into data. Hold on. Right. That do. Oh crap. That's changed. Yeah. There we go. Right, yeah, that seems fine. Quite a few cycles, but okay. Alright.
I have an important question for you. Imagine there's an out-of-control trolley and 5 humans tied up on the track ahead of it. But you can stop the trolley by... Maybe if... No, that wasn't the one I was going to ask. Recalibrating. Say you had a friend, and you knew the friend could help you become stronger. Would you ask for their help? Let's say it was a situation where the friend had to sacrifice something in order for that to occur. Okay, good to know. I'm going to process this information.
I'm going to retrieve a specific file for right. Find file 276 in the network. Bring it back to your host. Note that an exer cannot grab a file that's being held by another exer. So, right, so it's always held by an exer. in various different places. It looks like it can be any of them. Right. Well, what we effectively need is a tree search algorithm. I mean, alternatively, we can just spin up. How many X's am I allowed to have? I guess 9? 2, 3. Yeah, okay. So I've got two approaches that I can do here. I can either do one Exa and send them on their own out to effectively do a tree search. And then I just need to be able to identify which one successfully picked up the file, which route successfully had the file, and bring that back. Or I can just have 8 X's and configure them to all individually go to one of the routes. But again, I need to know which one of them actually has the file. Which I guess means I need to know more about how actually no, because if the grab command doesn't do it, okay, yeah. Because there doesn't seem to be any commands here, at least, which is just, do I have a file right now that I can see? So that being the case, what's probably the easiest thing to do is just have them all go out, all do a kill and grab, and then all come back. That's 800. Good, 8. Okay. Grab 276. Link -1. Link -1. Link. Oh, link. Yeah. So if I just copy this and manually change all the links, it's not going to do wonders. In fact, that's probably going to be oversized, isn't it? Yeah, okay, this is going to be too big to fit on the leaderboard. Like, we're already over the leaderboard size limit. We'll run it anyway. We'll see whether it works. And because obviously this is just the brute force approach of send them all to different places. Bit of a binary approach. Yeah, that works, but it's messy. does it even look at like normal speed? Okay. That does it. Let's flatten it down to 1. Do it. Right. Okay. So we need to do 3 iterations of going down 800. The problem is, like, if you've got the ability to do some introspection of, is there a link 800, for instance, it'd be quite easy to write something that, yeah. Hmm. Let's go back to writing the obvious thing, is the all left search. So that is the basis for traverse all the way down the left hand side, kill whatever's in there if there is anything in there, grab the file if it's available, traverse all the way back and halt. Yeah. What we need to do is make it so that it recurses through back. Could try and just write that manually and just see how it looks. I mean, see, in a higher level programming language, you'd write this as a recursive function, but you would also be able to tell when you're at the root node in a recursive function. Like you'd probably use a tree definition that lets you discriminate between whether you're at a branch or a leaf. I keep saying root node, I mean leaf node, don't I? So, as far as I can tell, there's no instructions that actually gives us that. Like, there's no way to like, for instance, even following a grab instruction, there's no actual way to tell, do I have a file right now, as far as I can see? Like, it looks like all of the file-based instructions will just silently fail if you're not in a state where they're applicable. Unless this might work. Maybe? Because I'm actually storing the return, can I not jump back to what's in a register? Jump have to be to a mark. Okay, it has to be to a label. Yeah, no, if you're doing this recursively, you need to be able to do jump returns, and if I can't dereference a variable into a label, like if labels have to be static, I don't think there's a way of doing that. Can't see one, at least. Yeah, no, so labels have to be statically defined literal strings. You can't do a jump return. Although, what you could do. Oh. No, maybe not. Surely there must be a way to returns. Because otherwise I'm not really sure. How you would do this in a way that isn't a lot of instruction. Because the point is that there are too many branches to have to search to do it in 50 instructions. You're doing it all manually. I mean, I guess maybe there's a middle ground between my original overkill solution. So, like, for instance, you make 4x's, maybe that balance is better. Because the problem with 8x's was you were copying the whole path every time. So with 4, you're only really repeating up to these nodes. Yes. Still over the size budget. What? Oh. So a failed grab actually results in a termination, so that's actually a runtime error? I guess does it have to explicitly be file 276, or can it just be the contents of file 2? Right, that makes it harder because, as I say, there is no way of testing whether there's a file in a certain area without resulting in your X's getting destroyed, I guess. Yeah, I'm sorry to say I don't really have a better answer for that one at the moment, because the way I would want to do it is through a recursive call, but without jump returns, I don't really see how you could do that. Yeah, ideally, I need to look at like someone else's solution, because there's clearly something that I'm missing. Government. Any, not just. It had to be someone on my friends list, i.e., nobody, to be able to like watch a replay of that. I feel like I just need to see an example of that to clue me in on what the thing I'm overlooking is. Right. Locate the specified host. Or tape 3. Locate the specified entry. Tape back up. Create a file in your host. In the end. Name of the target host name. Available. It looks like we're required to go clock. Always file 200. So is that always 2 values against that? What's file 243? Names. Okay. Oh. Okay. Right, so that's going to be where we end up if we're in the right host. Otherwise, okay. So grab the file, move into area. and seek, grab the host name. If we're in the right host, then move to some new block of code. If not, seek and try again. Afterwards, seek back in the file. So in the hypothetical situation where we never get the right host, we'll just be stuck in this loop. But again, we seem to be willing to assume that the confines of what we're doing is always going to be a valid input. So that's good. So mark host. So now we're in the right host. Your host. You know what? What's probably going to be easier is I just make another X that sits here. Does a make copy M to F, copy M to F, copy M, F, hop. So he just sits there and makes the file that we need as our output. I will do copy fx, got the name in scope. Wipe, so we don't have that file anymore because we don't want to leave that lingering around in the network. Grab 200. And again, we don't need to worry about end of files because we know that we're going to find the record that we want in here. That makes things a bit easier. Rename that, just make it clearer. I'm gonna maybe on different test runs we'll find that a given record actually contains more than just 3 values, but we'll go with that for now and see how it looks. Right place. Click the file, grab that file. We iterate through everything file till we want. We're probably not the most cycle efficient solution, but decent size at least. And that's clearly not considered done. Create the specified file in your host. Leave done. Wait, does it want me to bring 300 back? Like, why is what I did not... Why is this not acceptable? Wait, hold on. Accessing data and legacy storage issue. Oh. Right, okay. Helps if I actually read how you meant to interpret these things. So, okay. Get the data for the entry, you look up the name at the end of the file. You then use that to get an offset and a length. Right. Okay. That means this can be made better. If we seek to the end of the file, and seek back 3. Just that. Okay, so then we're okay. So that means we're going to the end. Then going back 3. Is that gonna work though? When we test that, it's gonna no. We're here. 1, 2, 3. That doesn't seem I'd like it, does it? I need it to be like a seek -4 iteration. Although, given that we've assumed that we get those values, what do we then need to do? Because currently we've only got the only purpose of XB is to sit there and be the writer. We need to store these out. Actually, what I could do is okay. Right. I'll worry about this. But if that makes a file, we expect to feed that the 2 F copy F seek -2. Yeah, okay, let's go. Right. So that works, apart from finding the record. Where currently we've gotten off by one error. The problem is, when we're at the end of file, we need to go back 3, but after we've done a test... This is probably the easiest way of doing it. Seek -1. Seek. A little bit clunky, but we'll try it. Let's see how that looks. You go over to there, that test fails, that correct. You cache that value. Delete that file. Grab to the end. Go back. Now this file has our cached offset and length. Wait, what? What just happened? Why did XA just die? Okay, found that. That forward, copy that over to there, copy that over to there. Seek to begin the file. Offset by that amount. Copy that. Test it. Oh, that's... I forgot. And... But now... Isn't it? Why is XB still waiting for input? Both should have the same offset. Oh, for God's sake. FM. And I actually need to subtract. From my length count. Okay, low on cycles, kind of high on size. I'm okay with that. What have I been streaming for? hell is this? So this is just a form of solitaire then. Alright, alternating. I think there must be moose. I guess I could pick up that kid. Six gone. But and just sit on the back on the rail once you've got space. Like there's nothing. Like a 10 can't sit on a jack. Makes me long for Windows Solitaire where I can just mash the help button. So it show me what my move is. There's not a... I don't think, anyway. These can't go anywhere. Oh, can suits any order? Oh, any order. Okay. Oh, does aces count as suits? What's that?
Special delivery. Whatever it is you're doing for money, it's working. Makes me wish I had a line like that. More control over my life. I found out something interesting the other day. You ever hear about these things called X's?
Exit?
They're these little guys running around inside computers. They make it all work. Banks, commerce, government, anything you can think of. Funny how it's all based on the same stuff on the inside. Just something I've been thinking about lately. Anyway, see you around. Got a feeling I'll be making more deliveries.
I don't know how much I'm doing this for today. Right. Okay, Ember2's user file in the user's host and overwrite it so some of the values is the same, but no individual value exceeds $75. All values except for the last must be the maximum value of $75. You'll need to add additional values to it. Ember2's username is available in file 300. Note that the sum of the values in Ember2's account will always be less than 10,000. Presumably that's because of the 9,999 limit. For more information, see Network Explosion Warehouse. Up. So user database. First you'll see a user's host which contains a file for each account. This file is the user's name, date of birth, and a log of how much money that user earned each day. Workcast doesn't want people defrauding them, go figure, so they presumably use this as part of a tracking system to make sure the job database. Then there's a jobs host which contains information about the currently active jobs which can be offered to users. Task database. Okay. So user file and user's host. Overwrite it so that the sum of the values is the same but no individual value exceeds. So I assume I can grab file from register. Yeah, file. Grab register. Oh wait, hold on. So I have the username. Okay, so I have the username in 300. And then in file 199 is the lookup from username to... Okay. Right, okay. So now I've got the file. Seat 2, because we don't care about the name or the date. What I assume is meant to be date of birth. Right. Overwrite it so that the sum of the values are the same, but no individual value exceeds $75. All values except for the last must be the maximum value. Okay. That's fine actually. That's actually slightly easier. I think that does the trick. Oh. Value. I'm sure we're probably not going to win on cycles here, but we've done alright on size. Average. Multiple odd. Okay. Expense all available cash. All connected. ATMs at the back of the network, see number of ATM. Victory first, 89 cents bills. So the cash register tells you how many bills are remaining, as how much money is remaining. If you write 20 to the disk register, it will attempt to dispense a bill, but if the ATM is out of bills, it'll send a daily message that alerts the bank. So be careful. I mean, okay, so this is another instance where being able to write a recursive function, or rather being able to write a jump return, would be useful. Because once you're in an ATM, what you need to do doesn't change, but getting to each ATM requires some manual effort, I guess, without a jump return. Well, first things first, we need to get the Exa in position. I guess... should I just do this the same way I did it last time and just farm out 5 X's and just... or does the number of ATMs change? The number of ATMs changes. Okay. Yeah, so farming out 5 X's doesn't work. Okay. One, two, three, four, five. So with 7 X's, you can just let some fail, I guess. But again, unless you can do this in very few instructions per Exa, let's just go with that. It gets us clear of it anyway. Right, so all it says is the cash register tells you how many bills are remaining as opposed to how much money. If you write 20 to the dispense register, it will attempt to dispense a bill, but if the ATM is out of bills, it'll send a failing message that alerts the bank. So, test cash equals 0. So yeah, we've got 10 instructions there. So that's going to put us over, again, the imposed size limit. So we know this isn't, quote, the right solution. Oh, actually, hold on. I know what I'm missing. Do I? Create a copy of this excerpt and jump to the specified label in the copy. Oh god, well, that's what I need. Okay, so I just need to make one. Right. Do I even need this? Don't need that, and then hide links. This is probably what I needed to do the branching one efficiently. Oh. There's probably a ideal way to get all these numbers in rather than treating them all as constants. There. Actually, wait, hold on. It creates a copy of the exa and then jumps to a label. So does that? Okay, I know how we don't need all this because if it copies the register state as well, so we can move to that area. We can set copy 800 to X. Then we do. Right, I think that works. So yeah, so we move into this location. We stash the value 800. Then we have a loop that says from 800 to 806, keep making copies of yourself and send them into each of these places. And once they're in each of those places, it'll just flush. Where was that? Oh, I didn't move forward far enough in the link. Although, can I? Do I need to dispense one at a time, or can I just multiply that number by 20? Or is that going to be too big? That work? No, they can't store a number bigger than 10,000 or bigger than 9999. Is that right? Yeah, so the docs aren't clear about whether or not you can dispense multiple notes at a time. Clearly, this multiplication isn't working. I mean, just for avoidance of doubt, can I? If I just put 40 in there, what happens? Will that actually work, or will it only take 20? It will only take 20. Okay, fine. That's fine. It does look like it was taking a while, but if it can only spit out one note at a time, that's absolutely fine. yeah, the way this histogram works, clearly there are just different approaches that just work notably better. But again, without being able to spit out multiple quantities of money at a time, I don't know what to do. Alright, I think I'm gonna go back and do that branching one, just because I realised that using that command to spawn new X's is probably the way you're meant to actually do it, rather than just doing that manually. And then I'll probably call it a day there. On the network 1, this was it. Right. Right. So. So we're moving to this zone. We want to branch left or right. The command again to create a new it. A ripple. Reply, ripple. All on. Right, so that's a lot better than we were. I suspect the way we bring down the size is to do something smarter about the branching rather than doing a copy into register and then overwrite into register. Can't do bit masks in this, can we? Because the easy way of doing it is just masking against 1. What's this swizzle? Swizzle the value of the first operand using the value of the second operand as a swizzle mask and store the result into the third operation. The swizzle instruction can be used to rearrange and or extract the digits in the number as shown. Oh, okay. No, that's not quite what we want, is it? No, we don't have any bitwise operations. 'Cause I was going to say you could use bitwise operations just to keep toggling the one digit, because you only care about between 800 and 801. So if you just keep XORing against a value of 1, it'll just keep bouncing between 800 and 801. But looks like we don't have bitwise operations in this language. Whatever, it was improvement. It's clearly what I was meant to be doing in the first place. I just didn't acknowledge that instruction existed. Right. Well, I'm probably going to call it a day there for now. Coming up on 3 hours now. So, goodbye to whoever may be watching.